Module 5, Lesson 7 deals with equivalent algebraic expressions. The content objective says that the students will identify and generate equivalent algebraic expressions. I think the distributive property may be involved here again, and it suggests that it's going to take 135 minutes. I don't think the last lesson was that bad, and they said it was going to take that long, but this one does have 21 resources in it, so it might take a little bit longer. Video games are one of the most popular activities in the world today. Some of the first video games were developed in the 1950s and simulated activities such as playing tennis or chess. Games of today have been built on that foundation and become increasingly complex. They have many hours of unique content where new activities are around each and every corner. Suppose Andrew's mother gave him a video game and $10 for his birthday. His aunt gave him 2 video games and $5. How could you write an expression to represent the total value? These are some of the things we're going to learn about as we dive into this lesson. Our inquiry question says, how can you use mathematical rules and properties to identify equivalent expressions? Well, let's dig into this and find out. Here's a list of algebraic expressions that contain the variable a. Which expressions would have the same value no matter what is substituted for a? Be prepared to explain the method you use. You can use the algebra tiles or any other method. Well, right here I'm seeing 4a's, and right here I'm seeing 4 times a, or 4a. So that this one and this one are both going to represent the same value because they both involve 4a's. But here I got 2a's plus 2a's, which is also equal to, once again, 4a's. Coming over here, I have a 3a plus a 1a. 3a plus 1a is equal to 4a's. I've got 4a's plus 0. That's going to equal to 4a's as well. And I got 2a's plus 1a plus 1a again. That and 2 would equal to 4a's. Now I'm not going to waste time using algebra tiles on that. I think it's pretty clear how each of those add up. This one, 5a, obviously not 4a, and this one is 3a plus 1. And you could easily get confused with that, but we don't know the value of that 1. We don't know that that 1 is what a is, and because of that, we can't do anything with it there. How about this one? Which one of these could be said to have the same values? Well, I've got 2a's and 2b's here, so that's going to be my starting point. And from there, I've got 2a's and 2b's, all of them adding together, so that one works as well. Here I've got the same 2a's and 2b's, all of them adding together. Now this one is 4 times a times b. That's not 2a's. That's not 2b's. Okay, that's 4 times the product of a and b. Definitely not going to work. This one here, 2a's and 2b's, that one's going to work. This one is close, but you have addition here. You've got multiplication there. That's a problem. The distributive property was used on this one, 2 times a plus 2 times b. Yep, that's going to be the same thing. And then you have 2a plus 2b plus, that one would be 3b's. It is a loser, making these the valid answers to go with that problem. Now this one wants us to do the same basic thing, highlighting everything that would be a sum of 2a plus a 4b. So we can do that real quick. Here you have 2a's and 4b's added together. That one would not be, because it's 2 times the sum of a and b. You'd never get a 4b out of that. Here you got 2b's and 2b's, that's 4b's plus 2a's. That one's going to work. Here you have 2b's and 4a's. We got to have 4b's and 2a's. And this one, 2 times 2a, that's 2a. 2 times 2b, that's going to be 4b. So that would work. And this one right here is also 4b plus 2a. And my answer checks. Pretty easy math there. And with all that said, let's actually start doing the learn activities. Equivalent expressions are expressions that have the same value. Vocab word. Algebraic expressions are equivalent when they have the same value no matter what value is substituted in for the variables. You can write an equivalent expression by applying properties of operations to an expression. And here you can see in numbers and words, the order in which the numbers are added or multiplied does not change the sum or product. That is going to be your commutative property, really important property. 7 plus 9 is the same thing as 9 plus 7. 8 times 4 is the same thing as 4 times 8. Same thing here. A plus B equals B times A plus A. A times B is equal to B times A. The associative property we've also talked about. It says grouping doesn't matter when you're just adding or just multiplying. So 3 plus the sum of 4 and 7 is going to give you the same thing as the sum of 3 and 4 plus 7. 7 times the product of 6 and 2 is going to give you the same answer as the product of 7 and 6 times 2, and there that one is with variables. And then you have your distributive property. Your distributive property says 2 times the sum of 7 and 9 is the same thing as 2 times 7 plus 2 times 9. 4 times the difference of 5 and 2, I don't know if we've used distributive property for subtraction yet, is the same thing as 4 times 5 minus 4 times 2. And right here you can see that one with variables. And then you have the identity property. The identity property says 13 plus, or any number plus 0 is itself, and any number times 1 is going to be itself as well. You see it with numbers and you see it with variables. These are the 4 properties we're going to be using as we continue on with this lesson. It'd be a good idea to study them before you get too deep into it. So let's apply some of these properties here. First, I want to just look at the variable side of it and identify them. Right here, that's going to be your associative property of addition. Order doesn't matter when adding. This is going to be your distributive property. And this one right here, well, that's going to be a distributive property as well. So, and over here, of course, that one's going to be your commutative property. So we have to drag all of them to the correct bins. So we got bins down here. My associative property, that one's going to go in the associative property bin. And let's make our screen a little smaller here. We've got the distributive property. That one's going to go there. We have the commutative property. That one's going to go there. And we don't have any variable one for the identity property. But 13 plus 0 is 13. Yep, that's an identity. Here we have flipped the order of the numbers. That's going to be your commutative property of addition. Here we flip where the grouping symbols go. That's going to be the associative property. And the last one, we've taken and distributed the 2 through the grouping symbols, making that your distributive property. All of our answers checks. Pretty easy to do once you know how the terms are done. But I expect you all struggled with that a little bit. It takes a while to memorize how the properties work, and you really need to spend some time working on that. So let's watch this animation on how the properties of operations can be used to identify equivalent expressions. Maybe if I can get it to play.
You can determine whether the expressions 4 times the quantity 2x plus 3 plus 5 and the quantity 4x plus 3 plus 5 are equivalent by using properties of operations. Begin by using properties to simplify the first expression. Apply the distributive property to eliminate the parentheses. 4 times the quantity 2x plus 3 becomes 8x plus 12. Then use the associative property to group and combine the like terms 12 and 5. The first expression simplifies to 8x plus 17. Now use properties to simplify the second expression. Apply the associative property to group the like terms 3 and 5. Then add. The quantity 4x plus 3 plus 5 simplifies to 4x plus 8. Use the simplified forms of the expressions to draw a conclusion. The simplified forms have different terms. The expressions are not equivalent. Now consider a different pair of expressions, 8 plus 3n plus 2 and 3 times the quantity n plus 1 plus 7. Once again, start by using properties of operations to simplify the first expression. Apply the commutative property to change the order of the terms. Rewrite the expression as 3n plus 8 plus 2, and then use the associative property to group 8 and 2. Simplify the expression to 3n plus 10. Next, simplify the second expression. Apply the distributive property to rewrite 3 times the quantity n plus 1 as 3n plus 3. Then use the associative property to group 3 and 7. Simplify the expression to 3n plus 10. Use the simplified forms of the expressions to draw a conclusion. The simplified forms have the same terms. The expressions are equivalent.
Holy buckets of bat poop, Batman. That is some hard stuff. I am honestly shocked that we're hitting you guys with something this tough in the 6th grade, but clearly they feel like you're capable of it, so we're going to take and see what we can do to help you get where you need to be. The problem is asking whether or not 3 times the sum of x and 7, all plus 2, is going to be equivalent to 5 plus 3 times the sum of x and 6. To find out, we're going to have to simplify both expressions and see whether or not they match up. So let's get started. First off, and I'm going to walk you through what they're doing. I'm going to show you on their lines here, and then when we do the extra examples, I'm going to show you line by line how I would do them. First thing they did is they distributed the 3 through the grouping symbol. They made a pretty big leap here. Heck, I'm just going to show you what I would do because this is too much of a leap. So here we are, written out my problem. I'm going to start off by using my distributive property, which is going to give me 3 times x plus 3 times 7. And from there, we're going to add the plus 2 to it. The laundry's fixing to send me that reminder that I need to fold clothes. 3 times x, that's going to be 3x. There's a reminder. 3 times 7, that's going to be 21 plus 2. Now we're going to use the associative property, which says the grouping doesn't matter when all you have is adding. So that's going to be 3x plus 21 plus 2 is going to be 23. And that is going to be the first number. And that shows you what they did right here to get their 3x plus 23. They just made a pretty big leap to get to that first spot. Now I'm going to take and go down, or move over, and here's their next problem, and I'm going to work that one separate too. So that one is going to be 5 plus 3 times the sum of x and 6. I'm going to come over here and grab my green marker, and I'm going to say 5 plus 3 times the sum of x and 6. That means I have 5 plus 3 times x using my distributive property plus 3 times 6 using my distributive property as well. Simplify that down. 5 plus 3 times x is 3x plus 3 times 6. That's going to equal to 18. Now I'm going to use the commutative property of addition, which says order doesn't matter when adding. So I'm going to flip the 5 and the 3x. So I have 3x plus 5 plus 18 is equal to. And then from there, I can take and say 3x plus 5 plus 18. That is going to equal to 23, which incidentally is the same thing I got there. So, do those represent the same values? The answer is absolutely, they are going to be equivalent. This is the supporting work the textbook gave, but they're not really showing you how they distributed. I really think it's important to put this line in here showing how the distributive property actually happened on this problem. That is where we're going to stop for part 1 of this lesson. Come back to work on part 2 with us, where we're going to start off with this one, where we're going to try and determine whether or not these two values are indeed going to be equivalent. And I think you're going to find this one's pretty easy. See you in the next video.